Hello. In the previous couple of videos, we were talking about the elementary row operations on the determinants. Now, in this video, we will do conclusions and some examples. So, suppose you have a matrix A and you make some changes in it, and the changes which are Ri interchanged with Rj. So if I interchange any two rows or any two columns, this means if I interchange any two rows, then I will get a new matrix B. Okay. So if I apply the determinant on both of them, the theory which we have developed previously says the determinant of A equals negative of the determinant of B, or determinant of B equals the negative of the determinant of A. Okay, so I will write determinant of B equals negative of the determinant of A. This is the first conclusion. Second conclusion is, again start with a matrix A and multiply its any row with some scalar constant K. For example, I multiply the ith row with a constant K, then I will get a new matrix B. Okay. Then the determinant of B is K times the determinant of A. Okay, this we have also proved. Determinant of B is K times determinant of A. And the last point is, if you have you start with a matrix A and do perform the operation Ri plus K times Rj, and you will get some new matrix B, then the determinant of A and determinant of B both are equal, means after applying this kind of operation, you will get no change in the determinant. This means determinant of A equals determinant of B. So this is the operation which makes no change in the determinant, but the previous two operations make changes in the determinant. Now let's do an example. So in this example, we have to evaluate this determinant. So what we will do, we will make here 1 and here 0 and apply the elementary row operations. How can I make here 0? Because this is 1. If I subtract this 1 from here, then I will get 0. This means if I subtract R1 from R2, I will get 0. Make sense? Because this is R2 and this is R1. So the first operation which I have to perform in R2 is R2 minus R1. And then I have to make here 0 also. Since this is 1 and this we can use to make this 0, so 1 minus 1 is 0. And how can we obtain 1 minus 1? Because this one is from R3 and this one is from R1. So R3 minus R1. So this operation is performed in R3. So in R3, I will perform R3 minus R1. So these operation I will perform. Okay? Okay, the first row will remains the same because I don't want to perform any row operation in it. So R1, A and A square remains the same. Since I have to perform R2 minus R1, so I will write 1 minus 1 here, B minus A here, and B square minus A square here. And since here I have to perform R3 minus R1, R3 is 1C C square, 1C C square minus R1 means 1a and a square, 1a and a square. Okay, so now I will simplify this thing. When I will simplify, here I will get 0, here I will get 0, so I have written here 0. Okay, now if I expand this determinant along this column, I told you previously that you can expand the determinant along any row or any column, you can do that. Suppose if I expand this determinant along the first column, the first element is minus 1 to the power 1 plus 1 times 1, because first element is 1, times the determinant obtained by ignoring the first column and the first row, this determinant, okay, b minus a, c minus a, b square minus a square, c square minus a square, plus, because I have to expand it along this first column, okay, first entry, the cofactor related to the first element has been done. Now I will do the cofactor related to second element. Since second element is 0, so the cofactor is 0. And similarly, the third element is 0, so the cofactor is 0. So I will have 0 plus 0, okay? Only this term will left. So this is equal to this element, okay? This determinant. Okay, now if I do some factorization, this is b minus a, this is c minus a. Since b square minus a square has the formula says from algebra, it says b minus a into b plus a. Okay? If you want to prove that how this formula works, just multiply this number, this with this, then this with this, then this with this, then this with this. You will get b square minus a square, okay? So instead of b square minus a square, I will write this, its formula, b minus a into b plus a. Similarly, here c minus a into c plus a. Okay? Now I can take common b minus a from the first row. You can check in the first row b minus a is common, so I can take b minus a common from the first row, okay? And similarly from the second row I can take common c minus a, so I will write c minus a times, what's the determinant here? Since in the first row b minus a is already taken common, so here I will left with 1, okay? So here I will write 1. And here, since b minus a is already out, I will only left with b plus a. Okay? If we go to the second row, in the second row, c minus a is already taken out, so here I will write 1. Look at here, since c minus a is already taken out, so I will left with c plus a. So I will write c plus a here. Okay? Now, things are very simple now. b minus a times c minus a. You know the determinant of 2 by 2 matrix is just the product of these two minus the product of these two, okay? So I will write the product of 1 times c plus a, 1 times c plus a, minus 1 times b plus a. Okay, b minus a times c minus a times c plus a minus b minus a. Multiply one inside here with c and as well as with a, you will get this thing. Then multiply minus 1 with b, you will get minus b. Then multiply minus 1 with a, you will get minus a. This a and minus a will get cancelled. You will get b minus a times c minus a times c minus b. If you want to write this answer more nicely, you can take common minus from these two terms. You will get a minus b, okay? And similarly, if you want to write this thing in the nicer way, okay, write this thing as it is, c minus a, and take this, b common, minus common. I will get my b minus c, because if I take minus common, so it will become plus and it will become minus. Okay, so therefore minus is common. It became minus and it became plus. Okay, we have taken two minus common, this minus and this minus. Both of the minus will kill each other, so I will left with a minus b times b minus c times c minus a. Okay, so this is the result. This result is also okay. If you want to write it nicely, this result is nice. Okay.